All right, good morning, good evening, or wherever you are. So we are reviewing today platform-specific APIs and how we model them. I might be slightly biased in this review because I proposed the API shape. So I will try not to impose myself too much because I also will be taking notes, which looking back was probably not a good idea, but also helps me to focus. So I don't know who was on this thing last time, but I will just start from the get-go so that we get all on the same page. So effectively, let me just scroll down here. So we just go to usage first and then we can focus on the APIs later. So basically there's a few things you want to get out of this. So it starts with the fact that starting with .NET 5, we have new TFMs that allow you to target particular operating systems, right? So the ones we envision are Windows, iOS, Android mostly. For now, and so the idea is in the project file you say something like net5-iOS 12, and then you may also say something like target platform min version and set it to 10, which basically means that you will still be compiling against the iOS 12 SDK, meaning you will see all the APIs that were introduced on iOS 11 and iOS 12 as well. But you still want to run your app on iOS 10. And so what that now means is, first of all, with this project configuration, we would like to record these decisions in the resulting binary, which we already do today with Target Framework. So there's the string netcore app, version equals 5.0 as we burn it in today. And we would extend that to also generate target platform and minimum platform attributes, which are both new. The attributes don't exist, so we will review those. And that's the string that we envision to record because it basically mirrors the string that's in the project file. Then we basically also have the idea that, well, now that you see the iOS 11 and iOS 12 APIs, how do you avoid a situation where you accidentally call new APIs without intending that? Everything compiles fine, and you run your app on iOS 10 for the first time, and then everything blows up. So we don't want that. So one of the things that we have for this is the idea that, first of all, you should be able to check whether you run on the platform. So there's a platform guard. We already have today runtime information is OS platform, and we would basically add a new API is OS platform or later, where basically you can pass in the platform and the version number, and we basically tell you whether you're running on this platform or not, and we would do the version comparison for you, because we know historically that people are really bad at formulating version queries apparently. And so the idea here is that we also have an analyzer that will honor this. So the idea is if you write the code naively, meaning you just call the iOS 11 or 12 API directly, then basically you will get a warning. And then when you actually write the platform guard on top of that, then the idea is that the analyzer is smart enough to not give you a warning. So this way you're not accidentally calling newer APIs, and you can also do the correct version checks in your code. Then there is the slight side effect of that. So the question is, first of all, how does the system even know that this API here is specific to iOS 14? And the answer is the API will be attributed. And so the idea is that the assemblies that give you access to the OS-specific APIs, which we call OS bindings, will have attributes pretty much in every single API that will tell you which version this API was introduced in, and our analyzer will use those attributes to give you the warnings. However, these attributes are not restricted to just the OS bindings themselves. You can also apply them to your own code. And so we already saw that earlier here is that the minimum platform version is already burned with the assembly as well, which basically means the idea is that your entire assembly will run on iOS 10. And then the idea is also you can say, well, maybe there's an OS API that is hard to call. So let's say you want to write a wrapper type around that you use by yourself. In this case, what you can do is you can just mark your wrapper type itself being platform specific, which now means in your methods that you have, you will not get any warnings because you already said this whole type can only be used when you're running on iOS 14, and then every part in your code that would use this wrapper type will now also have to do these version checks. So basically what you do here is you just forward the version requirements to the consumers of the code that you're authoring. And so that's basically the quick summary. So does anybody have any questions on that so far? Okay, that means no. Then let me scroll the way back up and then say these are the APIs that we are proposing. Maybe let's start with the attributes. Probably should have reordered that because hopefully that's easier. So there's effectively a few attributes. So today, target framework attribute is already in system runtime.versioning. So that's why I'm proposing we put all the attributes there as well. And
there's a hand raised.
Michaela?
Yeah, so I don't have a question so much as a fundamental concern, which is that in the original platform, in the original OS minimum version, I made a deliberate distinction between platform and OS because there's a kind of overloading of the operating system version and the API version. And that distinction, it does have some important consequences. And I'm not really sure how to message it to developers. But the fact is you can compile against an API version, and that really doesn't have that does not have a hard link to your OS version.
So
if you're saying your minimum platform version, that sounds like it has something to do with the API version, but it doesn't. It has nothing to do with the API version, really.
That's right. So I think I know what you mean. So we can talk about this maybe in more detail, but I think to me I understand the concern you have. I think in practice, though, I'm not sure it makes a huge difference because the idea is that from a user standpoint, like these things are syntactically very similar, right? The fact that they are semantically different, I think, just kind of falls out in the way you use them, right? So basically, if we go back to the sample code here, so you're basically saying like I want to target something that gives me access to iOS 12 APIs. The fact that this is logically here the SDK version or the OS binding version, I don't think matters much because the idea still is that what we put in this attribute here is effectively the version of the operating system that introduced that API. And logically, you're just comparing those for larger than or equal to, right? And so the idea is that I think syntactically, they don't make a huge difference, right? Semantically, yes, but I guess that's just in the way the usage is being done. I don't think it will cause a lot of confusion. Does that make sense? Or am I just not getting your concern?
That doesn't really align with what I've seen in reactions to the proposals. If we have that in this MS Build example that iOS 12.0 is the target platform version, that means the version of the API, right? It doesn't mean that you're targeting. It doesn't mean that you're baking any version into your app to say that it wants to use the compat versions for a specific API version, for a specific OS version necessarily. It might give you some kind of implicit bound, but it very much means the API version. Now, if you say target platform minimum version, that sounds like you're specifying some kind of range of supported target APIs.
So I'm not entirely sure I understand what you're saying. So you're saying the name of the attribute target platform is not great for this?
So target platform min version doesn't really have anything to do with target platform version. Target platform version is an API version. Target platform min version, as you have here, is purely a runtime thing.
Right.
It doesn't have anything to do with the API at all. So by naming them so similarly, it sounds like it's a minimum API version, and it's not a minimum API.
So are you talking about the name of this property? Because this one I don't actually care. Like I just took the one because that was the one that already is in existence. So this one, I personally have zero opinion on that. Like if you want to rename this one, that is fine by me.
Yeah, and what do you mean by an API version? Because assuming that I understand how all this works, which could be wrong, the saying target framework net 5 iOS 12 means if this is distributed via NuGet, and if something else is building for iOS 11, it'll say that there's literally no asset in this package because you failed to find something that intersects in the grid graph.
Yeah, but it depends what you mean by building.
That's a OS version, not I just don't know what you mean when you're making a distinction between platform and API versions.
because the API version is the metadata. So like you can build against the metadata for iOS 12 and use exclusively iOS 11 APIs and set your min version to 11, and it's going to run fine on 11, and you don't have to do any platform checks or anything. Like it's the target platform, the target framework is purely the set of reference assemblies you have that you get to build against. And those could be revved to have new APIs that are in a new OS version, or they could be revved to have newer helper APIs, and so on. But they affect the APIs that you have access to at compile time.
Right, but they also affect what at build time, if again assuming NuGet, if you've said your target framework is Net 5 iOS 12, then something building for a lower iOS version won't see that this has any, like the output of this compile does not exist on any iOS lower than 12 because nothing's in the NuGet package at that target. It would say this project you're trying to reference a thing that can't be built in the target environment.
It sounds like the concern is you say your min version is, for example, Windows 19.041, but you're only using APIs from, let's say, 15.086 or whatever the version is.
Sure.
In which case, the app will actually run successfully on 15.086, even though you pulled in the WinMD file for 19.041. And so this sounds like maybe a potentially separate analyzer that should exist that says you're targeting a min version that's higher than the highest version of API you're actually using. Is that a correct summary, Michaela?
No. And I think I think this is beginning to reveal how like some of the confusion around these. They are just. So there's a spec I wrote which has a whole section on like the different different version concepts and the relationships between them.
So basically, like, let me just summarize. So if I understand this, there's three version numbers. There is basically what API level are you targeting, right? This is basically, like, logically, the model that we want to more or less have is that people generally compile against the latest API version. Mm-hmm. Then there is the what version of the OS do you want to be able to run on, which is, basically it can be higher than the API version, which is the normal mode that we are all used to, right? You compile against something older, you run against something later, right? That's easy. Then there's the model where you want to compile against something, latest, which is the latest SDK, let's say, but you want to be running on an operating system that was shipped 3 years ago, right? And so what that means is you can't call APIs that were introduced after that OS was shipped, right? And so that's where this analyzer that we talk about here kind of kicks in and tells you when you're calling these APIs incorrectly, and then the expectation is you guard the call, right? And then there's the target version, which is kind of like you can think of it as like a quirking mechanism, right? When you look at Windows, for example, we have this manifest file where you can say, yes, I tested my app for Windows 10, or I tested my app for Windows 8 or 8.1, and that kind of controls how the operating system thinks about your app, right? If you're saying my app was designed for Windows 8, and then you run against Windows 10, then maybe you get additional compatibility quirking from the OS because they changed some behavior somewhere. Versus if you were compiled for 10, then they would assume that you tested on 10, and then you would get the right behavior. And so basically this is what the target version really means. In our world, we basically, like in .NET world, we only have one today, which is basically the target framework, right? And so what we're doing with the OS part is we basically say, yep, you also be able to target the operating system with the same mechanism. This is what this des suffix here does. But what that basically controls is kind of like what you are compiling for, right? So that may give you access to the latest iOS SDK, but you may still want to run on an older version, and that's what this min version thing is doing. And then there is the target version, which is the quirking behavior, which I don't think we have a representation for quite yet. But that's basically the third version number. Is that a fair summary, Michaela?
Yeah. The target version is a concept that exists on Android, for example. It doesn't exist on iOS, so that one in particular is not universal. Yeah. So the API version purely affects what metadata you get at compile time, and the minimum OS version purely affects what OS versions your application is allowed to run on.
Right. So if you built something with this project as described right now, what is NuGet going to say, or what's it going to look like in the resulting NuGet package? Is it going to carry itself as net5 iOS 10 because the min version overrides the where it goes in the packaging hierarchy?
It will carry itself as net5 iOS 12 because that 10 version has nothing to do with the compile time and nothing to do with the assemblies.
Yeah, so think of it this way, right? So if in the lib folder name, you will see this name here. And so the normal NuGet rules will apply. So that means if a consuming project has a target framework of net5-iOS 10, then you will not be able to install the package because this package might use APIs, in the public surface, new types they've introduced in iOS 11 or 12, which will now basically cause the consuming project to not even compile, right? So that's why we give you an error. Now we will also carry the min version, but we will carry this effectively as additional metadata in the NuGet package. And then the idea is that, yes, there will be a rule in NuGet that will basically compare the min version that the package has with the min version of the consuming project. And generally speaking, it's okay if the consuming project has a lower min version because it means you can guard your calls into that library, right? And so that's basically where this other attribute here comes in, because that just falls out if you mark the whole assembly with this. It basically just means that the consuming project will get warnings if its own minimum version is lower than 10, right? And then basically you just got your calls.
So is part of this that something in NuGet resolution has to account for all of this?
Yes, so there's multiple specs that we wrote, and I have not done a good job of reconciling them, but yes, there's multiple work items on this, and one of them is the metadata encoding in NuGet, and then the resulting warnings that come out of that, which is basically what the analyzer will handle implicitly.
I was taking NuGet as invariant, which changes a lot of my assumptions. Yeah. So thank you for that data.
So this particular confusion has come up pretty much every time, and I think part of it does come from the naming of the target platform min version, because it sounds like it is related to target platform version, right? It sounds like it's a minimum bound on target platform version, but it's not actually. Like it has an implicit, it has kind of an implicit bounding relationship, but they're not directly linked.
Yeah, so that's what I'm saying. Ignore the name here because I just picked the one from the other one. What's more important to me in this work item here is the name of the attribute, because that's kind of what's proposed here. So and here you can see I didn't use the term target at all because it doesn't make much sense.
The reason I brought it up is so I do have a different name spec'd for the MS Build property, but if we go with that, which is OS min version, then would it make sense for the attributes to be minimum OS rather than minimum platform, so that it aligns, so that people can see that these two things are directly linked?
So I would generally have no problem with that. It's just that, basically in MS Build, the concept right now is called platform everywhere. So if we go with OS for these things consistently, then I have no problem with also saying the attribute uses the term OS over platform. It's just that historically we have used the term platform to mean OS. And so I'm not sure that whether we can actually be consistent.
Yeah, I get that. I think the overloading is problematic. I don't know how to fix the overloading issue. That the overloading does cause confusion, that we have this overload between the compile time metadata and the runtime OS, and those are different things, which doesn't matter a lot of the time, but sometimes it really matters, and when it really matters, it gets incredibly confusing.
But that's related to targeting, right? That's not related to the term platform, right? To me, platform doesn't mean compile time metadata for the OS. I mean, to me, platform and OS are kind of interchangeable terminology-wise. It's really more the targeting aspect, I think, that brings up this thing of like, what API versions do you see at compile time?
Yeah. So maybe we should make the hard distinction that target platform means compile time and just platform without a qualifier, or maybe OS platform. Given that we already have OS platform, the OS platform enum, maybe we should go for OS platform to mean like the runtime. So we're a bit more
that makes sense
explicit there. So we do like OS, like minimum OS platform. Oh, and we already have like runtime. Yeah, so you have runtime information.is OS platform or later. So if we just make the assembly attribute minimum OS platform.
Yeah, that works for me. Minimum platform, minimum OS.
And I assume MS Build is going to somehow address the complexity of target frameworks versus target framework and understanding the min version and how they relate and cross compiles.
Yeah, I think there's a different item for that. I think Michaela proposed that we have different top level properties, so you don't have to like have crazy conditions on them. But like, yeah.
Yeah, there's a whole other issue for that I would be happy to talk about, but let's not hijack this discussion.
Yeah, so like, I mean, you can kind of ignore MS Build. I just give it here as so that we have something to talk about. Really, what matters is whatever the configuration looks like here, this information we would like to record, right? And so this is basically recording the framework name, which is basically the part before this dash. This is basically the part after the dash, and then this is whatever minimum you have specified, right?
Right. Well, I mean, I guess I'll go ahead and ask the question now instead of circle back to it later. But what I'm building up to is, in this, can we handle an assembly that itself, like, let's assume that there becomes an actual semantic difference in the rebranding of iPad OS versus iOS. Can you have the one .NET assembly that says, assuming their versions don't align, I have minimum platform of iOS 15 or iPad OS 14, and that's embedded in the same thing? Or do you now need to split compile to deal with the fact that changed and you can't do it with runtime information anymore?
So yes and no. So basically, so you will be able to author an assembly, like a single binary that will have APIs for iOS, macOS, and let's say iPad OS, because they happen to be 80% overlap, and then there's 20% difference, let's say, because the attributes are all multiple. You can always apply multiple of them, so you can mark the whole assembly as saying, yep, I have a minimum OS version for iOS that is 10, for iPad OS it's 15, and for macOS it's 9 or something, right? So that's possible. The problem is more here. So like if we actually have different, different basically different names for iPad OS and Mac OS, and then the problem is you can't really compile a single project for multiple TFMs at the same time, right? That like if you do multiple TFMs, you compile multiple binaries, right?
Right. This would be if you did net 5 and then said, by the way, iOS 10, Mac OS 9, and iPad OS 78.
Right.
So that your TFM was just the I don't care, or I'm not a specialized, I'm a generic. But if you're running on an Apple product, there are some extra concerns here.
Yes.
Yeah. So you could have a platform neutral assembly, i.e. net5 or net6 or whatever, which has annotations that say that certain APIs are going to only be available, are only going to work on certain OS versions, and that might be because you use bait and switch, i.e. your implementation was compiled against platform-specific framework. But your reference assemblies are neutral.
Right.
Our tooling for that is not super great, but it is a pattern that
Okay.
is fairly common that people use. Another way would be if your assembly is platform neutral, but then your implementation of some of your methods depends on another assembly, which itself has constraints on those, because use its bait and switch.
Yeah. So
I
another thing I want to point out is like in .NET today, both .NET Standard and .NET Core App, we have APIs that are Windows specific, right? All the ECL APIs comes to mind, registry comes to mind, right? So I would assume that we will use the minimum platform attribute on those, so that when you use them and you're not targeting Windows, you will get a warning.
Right. So I'm just trying to understand what the big scenarios look like here, because that's important in seeing if the things feel like they're meeting the scenarios.
Yes.
So we do think it is important that you have a target framework with a neutral TFM that does still participate in some of the minimum platform stuff here. And then that means if you're running on this platform, this is the minimum. But if you're not running on this platform, it doesn't apply.
Right.
Yeah. We could also factor. I don't recall if you had this emo, but there was definitely a suggestion that you could also annotate things to say it's not available on such and such a platform.
I mean the annotating the reverse.
Or like either we assume if it has any platform specific annotation, then you assume any platform it's not annotated for, it's not available, or if we have some explicit way to mark them as not available on such and such a platform.
Yeah, like I assume the former case right now for simplicity. But yeah, I'm not opposed to that.
That's fair, as long as it's defined.
Because I would assume that if you're platform specific, you either are in very narrow cases, or the whole thing more or less is platform specific, right? It seems fairly rare that you have the inverse. All right, let's look at the attributes. So basically what I have is I have simplified this significantly. There was a meeting that I think I invited Michaela to, but she couldn't make it, where we talked about the encoding of the attribute. I think Jeremy was there, Bill was there, I think Rainer was there, and Daniel was there. And so basically one of the problems was, before that we basically had the platform name and then the version broken out into components. And there was a lot of discussion about why we have 4 version numbers. It seems very awkward to use. Then Michaela brought up, independently of this, the problem that it's fairly ugly to put these attributes on stuff, because originally, if you look here at the usage side, originally we had things like name of OS platform dot, let's say iOS, comma 14, comma 0, comma 0, comma 0, comma 0, which now means these attributes are like extremely ugly to apply, right? Because they're very lengthy. And on top of that, we have other pragmatic problems where the name of will return the name of the field, but the actual content of the OS platform field is in a different casing. Then we have this problem with macOS right now, where it's not entirely clear to me whether we will even have macOS as a member, whether we just reuse the OS X one. So basically what we ended up with saying, like, let's just ignore the whole version thing. Let's just use the exact same string you put in the project file as one string. And then if people are annoyed with magic strings, they can just declare like their constants in their project file and reuse them. But then the idea is you only have as many strings as OSs you're targeting, so it's not super busy, and it makes the thing slightly more readable. And so if we go down with that path, then basically the attributes all become very similar in shape. So I just defined an abstract base type purely for grouping in the docs. So when you stand on this attribute, you can see all the ones that are derived from this. There's one that we already talked about, which is the target platform one. It can only be applied to the assembly because it just records what the assembly was compiled for. You cannot apply multiple because that makes no sense, right? Multi-targeting means you produce multiple binaries, and then each binary is just one slice. And it cannot be inherited because, well, it's an assembly level attribute, right? And then we just, I guess this one you can ignore. This is coming from here. I edit the base type later. So yeah, basically ignore that. This basically just derives from this, has this platform name on it, and then that's the end of it. So, and then the other ones are similar. So we have the minimum platform one. This one you can either apply to the whole assembly, which is what's done for the project as a whole anyway, but you can also apply to anything that is an API, right? So that's basically why it's class, constructor, event, method, module, property, and struct. Module is probably debatable because I'm not sure how much we care about multi-module assemblies these days, but generally speaking, I don't see why not. And then basically the idea here is if this thing is applied to an assembly, it means the entire assembly cannot be called from an earlier version by default, right? Like it's still, the way the analyzer will work is that it will walk the API shape. So if you call an API that's not annotated, we look at the the containing type and then its containing type and so on until we reach the assembly. So that means if you mark the entire assembly, if you don't say otherwise, it means the API is only available on that version. You can still apply the attribute to a particular API to say this one is available earlier or later. So that's fine because you just override effectively what that means. But this is basically the behavior you get. Generally speaking, it makes no sense if it's lower though, because if it seems a bit weird to say my project can run minimum on 10, but then you have one API that can be called from 9, because that seems nonsensical. So by definition, you would usually just annotate APIs with later versions. And then, that's pretty much the end of that. Does that make sense to people so far?
Well, so just to be clear here, that means that if you have one class that can be used to describe whether or not you expect things to run successfully, and it therefore has a lower or an any consumption model, you can't use the assembly level attribute. You have to put the attribute on every other class in the assembly. If you don't think it's a realistic scenario, that's fine. If someone had their version of like runtime information is OS platform within their own assembly, they're going to have to do complicated painting to make everything work, or use IL merge, or well, it wouldn't be IL merge. They'd have to do a much more complicated thing.
It's probably not going to be every other API though, because you will have some kind of baseline. Right.
But there is no this is the default, but I'd like to break out of it and be more general. It's this is the minimum, and I can be more restrictive.
Yes.
Mm-hmm. Yes.
Okay.
Because that's kind of your scenario makes sense in the abstract, but it doesn't make sense if you consider how we target things, right? Because you can't really build an assembly like that today, right? Because you have to put a target framework attribute in it. So by definition, your whole assembly is, at the very minimum, it's tied to what you were targeting, unless you specify otherwise, right? And the minimum just gives you a way to lower that, but you can't really have a way to say, oh, now I make everything neutral by default, right? That's not what we have.
That's fair. And then as a practical question, so I see that you have both the minimum platform and target platform, irrespective of what their final names are, as sealed. But the platform attribute, you have just a protected constructor on. Do you want that to be an internal or a private protected constructor so that it's not third-party extensible?
So we could. I mean, I don't think it's a problem here because this is just for grouping in the docs, technically, right? So like there's not really an implication that an analyzer is supposed to handle all derivatives of platform attribute, right? The analyzers will just look at particular leaf nodes, right? So in that sense, I don't care whether somebody derives from that, but it's also probably not useful.
Okay.
So I mean, I'm okay with making the constructor internal.
Yeah. Makes sense to functionally seal it by default if we don't have any actual scenarios.
What was the consideration for if the platform ever ends with a number? Let's say hypothetically they come out with WASM 2 and they decide to start that at version 1.
Yeah, I mean, like this came up in the meeting that I had with Daniel and Rainier. Like the problem is today, I'm okay with handling that, but to me that is not something that I want to just handle for the attributes, because we also have to handle it here, right? So like that would basically mean that we would have to come up with some sort of convention to separate the identifier from the version number, and that also needs to be legal in the actual TFM. So if we feel like that's a real scenario, then we should design the TFMs differently and basically add a separator there, and then the attributes would just behave the same way.
I've seen the names that we come up with internally, so I have no doubt that someone someday will come up with a platform that ends with a number.
Sure, but we can do very terrible things and call it like WASMTWO.
Mm-hmm.
Well, I
or
mean,
have
like
the platform end with a dash.
Yeah.
Yeah, I mean, like there's also the OS2 warp, right, which we all know of. Yeah, thankfully you can just put warp behind the version number, so it's working fine. I thought about this as well. Like, I just don't think it's super likely. But if we ever have to, we can always refine the parsing if we ever have to.
Like technically macOS, like OS X is OS 10. So there's also the Roman numerals approach.
Yeah, the terrible naming that we do in this industry. Yeah. All right, so then we talked about minimum platform version. So there's two more attributes which Michaela spec'd out originally, which is basically removed in and obsoleted in. So the idea here is that because we have the model that we want to generally have a singular SDK, moving forward, we don't want to ship multiple SDKs, right? We don't want to say, oh, .NET 5 supports, iOS 10 and up, so we have to ship an iOS 10, 11, and 12 SDK. We only would like to ship the iOS 12 SDK at that point, and then just tell people like, yeah, if you want to run on older versions, just put the min version in there. But that now has the problem that if Apple ever removed an API, how do we do this if our SDK model is basically accumulative, right? And then the idea is, well, you just put an attribute on this and says, yes, this was available up until version 10, and then it was removed, right? So you would have a minimum and a removed in platform attribute on the API, and it tells you when it was introduced, when it was removed. And then same thing, our analyzer would tell you that if you're running on a platform potentially greater than that version, equal or greater than that version number, you would get a warning that tells you that, well, this API is no longer there, so please guard your call. And then obsoleted is kind of similar. It would behave like our obsolete, except that it's also has to consider the version number you're targeting. But same behavior, basically. I didn't put a diagnostic ID here because I think of these as platform APIs, so I'm not sure that they warrant a different diagnostic ID, because that's something that Apple would control or Android would control. And so the best we would usually do is we would just tell people like, here's a URL. But otherwise, we are now in the business of deciding, oh yeah, this obsolation is different from this obsolation. And that seems kind of something I don't think we care to do. We would just mirror whatever Apple and Android and whoever else owns the SDK controls, and we would just mirror that.
Might we want to have a message though, so that people don't have to go look up the URL? If it's just something like use XYZ instead, it would be handy to be able to surface that.
Yeah, message may be interesting. My concern with message is because it's in the assembly, we can't localize it, and so that's the general downside with messages, which is why I think URLs might make more sense. But you're right. I mean, if Apple doesn't get bothered with a URL, then maybe the best we can do is we have just generic release notes for this release, and we just list all the obsoleted ones, and then we can translate the doc page if we want to.
I would argue an untranslated message is probably more useful than no message.
That is fair.
What are we expecting to happen for remove, so going with just the numbers we've already talked about, if you said your minimum is 10, your target is 12, and it says it was removed in 14, should you get a warning on every time you call a thing that has been marked as removed?
That's not possible. You couldn't get it removed in 14 if your target is 12.
Yeah.
I thought we said we were just only wanting the one set of you could be running on 14. Do we not want to know that things are removed in the future?
This goes back to the confusion that Michaela was speaking about. So think of it this way here. So think of it kind of how .NET reference assemblies work, right? If you are compiling for .NET 5, you cannot see APIs in .NET 6, right? Because we give you the reference assembly set that can only contain up to 5.0, right? So the difference from the OS version here is that think of our reference assemblies as also being annotated. So when you target 5.0, we would also tell you, yeah, by the way, this was introduced in 4.5 or this was introduced in 3.0, right? What we can't support you in .NET is you can't compile for 5.0 and run on 4.5, right? Because that's not how metadata works in .NET. For OS bindings, though, that works. And so that's why we would say when we ship .NET 5, let's say the highest iOS version at the time is 12, we won't ship an iOS 11 on iOS 10, right? But that also means you can only see up to iOS 12 because that's the only thing we have. So if we now ship .NET 6, maybe the highest version of iOS at that point is 14. And then, yes, the 14 assembly set would now tell you that this API was removed in 14. But as soon as you compile against iOS 12, you will only see up to iOS 12. You can't see anything later. But you will see everything earlier, right? So that in that sense, you only see backwards, when you cannot see forwards in time.
Okay. That makes sense.
All right. And so these are basically the three cases we have: added in, removed in, and obsoleted in, right? And then added in, we just said it's minimum because that makes more sense. Any concerns around that?
Hey, Emo.
Hey,
So
Booyah.
I'm wondering, there were before added in attribute, So I'm just wondering how that will apply to these new attributes, for example, target platform and minimum platform attributes.
Yeah, so added in is effectively minimum, right? So added in basically tells you which
Okay.
version the API was added in, and that's basically what the minimum does, right? It says at the minimum you have to be on iOS 10 to call
What
this
if
API.
it's not? So target platform then just means don't need to check for target platform. Like if I
Correct. So
target platform is just for the runtime or something.
yeah, so target platform, I mean, we basically would just burn it in so that we have it, similar to target framework, right? We don't really use target framework much. It's just recorded in the assembly, so when you look at it, you know what it was compiled for. So you should not look at target platform at all. You should only look at minimum and then removed in and obsoleted in if we want to support the analyzer for that. But yeah, right now the only thing you need to focus on is this guy here.
Something that hasn't been said, but I think it is probably worth clarifying, is that if you don't specify a minimum OS platform, then the build will automatically burn in your target platform to be that value, right? Because if your target platform is iOS 14 and you don't explicitly say, I'm supporting an older OS, then it's going to assume that your minimum is 14.
Right.
And so that's burned in at compile time.
Yeah, so you should always, so basically you always have this attribute present, and it will be either exactly this version or a lower version, right? Because if you omit, yeah, as you said, if you omit this line here, we would just burn in this one. All right, so then attributes are covered. Then we can talk about OS platform and runtime information. So one thing that has come up before, which we should also talk about, is what do we do with the existing environment OS version thing? But before we go there, let's first focus on these guys here. So the reason we have these ones here was for two reasons. One of them was, well, our existing OS platform, our existing environment.os version has some enum for OSs which are no longer that great. So we basically don't want to use those, but the version number that is returned by it is still valid. But basically we wanted also to make sure that people don't really do version comparisons themselves. And basically that's why we have this API here where you basically say, are you this platform? And then we say yes, no. One design that falls out of this is that we can be multiple platforms at the same time. Now this may sound weird, but it's actually not that weird because, for example, we have Linux and we have FreeBSD, right? So we can say, yeah, FreeBSD is a form of Linux, but it's more specific to say it's FreeBSD. So in that sense, if you ask, are you Linux? Yes. Are you FreeBSD? Yes. And so in that way, we can also support this thing we had earlier when, iPadOS, maybe it's a specialized form of iOS. So maybe iPadOS will say iOS is yes, and iPad will also say yes if you ever add it, right? That's why we kind of have this inverse logic where you pass in what you want to query for and we tell you whether that's true or not, rather than we tell you who we are, because that will make it very hard for us to add refined choices over time. In that spirit, I basically said, okay, maybe we should have another API that is similar to the version checks that the Windows guys came up with, which is you ask for the version and we do the comparison for you. And so this is the same here. We basically say, here's the OS platform you want to check for. And then you can pass in up to 4 version numbers, right? People suggested to use the version struct here, but I think that makes it just harder to write the call, and it also makes it harder to analyze. So that's why I didn't do that. But basically, yes, you can just pass in up to 4 version numbers. And then we have the inverse as well, which is the lowercase check. Why is it lower and not lower or equal to? Well, because if you want to check whether, am I allowed to call this removed in API? You want to pass in the version number where the API was removed in, right? That's why I said, okay, it makes more sense to have an API like this, where you can say, yeah, you can call this removed API if it's an earlier version than whatever version number the API was removed in, right? Same with obsoleted. And so that's the only reason why you want to have the inverse case. By and large, I expect most people to use this one, though. Does that make sense to people?
Are we modeling FreeBSD as a version of Linux? Because it's
Yeah,
not.
because it's not.
Well, I just
It's
gave it as an
good.
example. Like, if it's not, then it's not. But like, I think the point still stands.
It's a Unix system which is POSIX compliant and has the POSIX APIs available, but it doesn't have any of the Linux kernel specific things.
Okay, then
Similarly to Mac OS is a Unix based system and generally has most of the POSIX APIs available.
so then replace what I said earlier. Replace the Linux with POSIX, but then the point still stands, right? You will be able to say this is a POSIX compliant operating system, and multiple might say yes, and then you can also ask for the specific ones, right?
Immo, a quick comment on this. I know you said you didn't want to use the version type in these parameters, but it might be good at least just to have an overload that takes them just in case someone already has an instance of that floating around.
Yeah, so I thought about that. The problem with that is if we do that, then is your expectation that our analyzer can handle that? Because that might be hard, right? Because now if you pass in a version, well, then we would have to find the place in your code where the version was constructed, which now means you have to data flow analyze your code and then find in which version numbers you actually specified. I'm not
Yeah.
sure we want that.
That also brings up maybe we should have the analyzer give you a warning if you use variables in these calls.
Yeah, I mean, the variables will be okay so long they're constants, because then we can still see the value.
Well,
but
then
yeah.
not variables, it's a constant.
Yeah,
Fair
well,
enough.
I think Michaela was saying non-constants, but yeah.
Yeah, like basically, yeah, like symbols are okay basically, but not values we
Yes.
don't know.
Symbols are okay.
That's
yeah,
fair.
because we talked about the literal expected for some of the stuff in intrinsics, and it seems like this would be, if we had that attribute, we would put it here, but we just may put that in the platform compat analyzer of like, hey, I don't know what it means to be. Am I later than version X where X was passed into this function?
Yeah, so one thing we should consider though, because everything is string based now, should we have an SOS platform or later that just takes the compound string?
Maybe. I mean, it would, when we talked about what the attribute should take, we did say that by accepting it as a unified string, it means you can have defined it as a const in one place and then just keep referencing it. And it would give equivalent value here. It does, I guess the platform compat analyzer is already going to have to parse that string to understand the breakdown. So
yeah,
doing it at the call sites here and doing it when the attribute comes out, it's the same parser. So as long as we use the exact same strings, it's not a problem.
Well, it's not just that, but if you look at what we do in our unit tests, like our unit tests literally introduce helper methods is Windows 10 RS5 or later. And we call those helper methods, which would delegate to these. But if those helper methods are used to guard a call site, will things fall apart?
yes, because you have no way of saying that right now.
Right, but I think I anticipate that's actually going to be the majority use case for these APIs. I don't think people are going to sprinkle these throughout their codes, throughout their code bases.
But then help me understand why these helper methods would be easier than basically a very simple version of these APIs. Like, why can't we make the call of these APIs as simple as your helper method?
No, what I'm saying is if I'm trying to guard a feature that exists on, like I said, RS5 or something, I'm not going to want to have these call sites all throughout my code saying, okay, OS platform .windows, comma 10, comma 19485 or whatever. Like I'm going to want to wrap all of that into a single helper method just called like, can I call this API? Yes or no?
I see what you're saying.
Right.
Well, in that case, I mean, this goes back to the string, right? If we would take a simple string, you could just define that string in your project file, and you would just name the string feature X availability, and you would just say this is, Windows RS5 or whatever.
Yes, that could work.
Yeah. And I think that people would be very apt to write the helpers if we did these across 2 releases, but if the analyzer that you're hoping will help you, and the requirements from that analyzer come in the same time that these APIs do, that's an immediate disincentive to write the helpers. But yeah, so I think the string will help make the code be more legible and easier to reason about, and it's no more complexity on the analyzer, given that we've already made it interpret the string from the attribute. So
yeah. So now let's talk about the controversial stuff.
Actually,
So-
I guess
sorry. Yeah.
To contradict myself, it means we've pushed the complexity into the runtime, because now the runtime needs to be able to split that and turn it back into the right answer.
To a certain extent, yes. That's the only concern I have with the string. But like to a certain extent, that's also true today, because somebody has to be able to answer, "Are you macOS?" Right?
That's easy. In runtime information, it's cross-compiled, and the DLL knows it was OS X, and it says return true if you asked for OS X and false for anything else. Once we get the string, that you need to turn that back into the identifiers we understand, which means we need the string parser to ship as part of corelib.
We don't actually need to turn it back into the identifiers, because we can actually special case that within the runtime itself. For instance, if I'm running on Windows and I receive a version string that literally does not begin with the characters WIN dash, like just return false.
Fair enough. But it means
you-
that we've pushed the complexity of the string parsing into corelib, and
I mean,
that would be the only cost, but it's probably worth it.
I mean, yeah. The only thing you basically have to carry is like every slice of the build needs to know its aliases, right? But you don't have to have total knowledge ever, right? Which is probably good enough,
Right.
because it just means today you already have to say if macOS true, you say, well, if macOS or OS X equals true, right? Like, I mean, that doesn't seem terrible.
Right, and what I was mentioning earlier is I think the implementation is going to have a lot of if-defs in it, but within any individual if-def, the actual shipping logic should be relatively simple. I would
the
hope.
Yeah, that's the hope. But now that's actually a nice segue to the controversial thing. So we have today an entry called OS X on OS platform, because we already shipped this 3 years ago, whatever, and we called it OS X at that point. And of course, it's not called OS X anymore. It's called macOS. Now, I originally had the macOS field in here, or property, I should say, and then I received feedback like, "Oh, we have OS X, remove it." I expect the friends like Michaela and others who build the other side of the house not be super happy with that. So now the question is, are we going down this path, or are we saying no, just have a macOS property here and just make it an alias for OS X?
I mean, at this point, anybody who's writing new code, like they did the rename long enough in the past, I would say add Mac OS and EB never OS X. We can't remove it, but so we'd make them be functionally the same in the runtime.
Yeah, I think that's actually a good idea.
But that's essentially, we're aliasing the member.
I'm also not. I don't think anyone here would be opposed if you just remove it. It's 2020.
Existing assemblies that already have it mean they can't roll forward. That's a binary breaking change. Like, you can't have built Net Standard 2.0. You'll built Net Standard 2.0 and you'll crash on Net 5.
You're also assuming that Net Standard 2.0, which came out like 3 years ago, someone's actually targeting that very particular member from a Net Standard 2.0 app. But yes, I get your point.
I mean, the
Like,
problem
it's-
is, like,
yeah.
it works today at runtime, right? Like, we do the right thing. So the question is, why would we go out of our way to make that not work? Like, it seems simple enough to just. I think editor browsable actually is a nice compromise, because you remove the complexity most of the time, and then it still works, right?
Yeah.
I think that's probably nice. Cool. So then that was easier than I thought. We only took an hour. That's unexpected. Anything else that we haven't talked about?
So, Emma, you, I think somewhere in here, and you talk about combining multiple platform checks. So if you do need to, if your code does need to check is OS platform or later against multiple things, I think people are still going to want to write helper methods to wrap those.
So
I don't know how to guard against that.
Give me an example for that, because I think the only things I can think of is basically the example that Levi had earlier, but I think a string-based overload will take care of that for the most time.
Ranges as well, right? If you need to check both the min version as well as the max version and see if you're inside a range, then they'd have code of is OS platform or later and is OS platform earlier than.
I mean, if we wanted to support helper methods like that, then we could do because C, or the latest version of the C# compiler for nullability has you can put an attribute on a member that says it makes this field or particular field not null. So we could have a return-based attribute or just a simple attribute on a member that is like guarantees minimum version and then takes one of these platform strings. So we could compose things based on that if we thought that was important. Ranges, I think, are still going to be hard because then we need an upper bound and a lower bound attribute.
Mm-hmm. But if we go with the strings and we get rid of the ints getting passed in entirely, we could introduce a helper method for a range.
I mean, basically what you would want is kind of an assert attribute at that point, right? Where you say this method asserts that the lower bound is this and the upper bound is this.
Right.
I mean, assert maybe the wrong term. It's basically like it returns true if that's basically it's something like the false if, or whatever we called it in nullability, where we say the return value is corresponding to this condition, right? That is possible. Like I would think, like to me that's kind of refinement of the analyzer. Like I'm not convinced that we need it yet. So I would start with that and see how far we get.
Yeah, because I think if we take the strings, then we've probably made it simple enough that people wouldn't feel compelled to write an analyzer or not a helper method to make their code be more legible. Because what you'll have is if runtime information is OS platform or later, platform IDs RS5, right? And like it says that right there. You can read what it says. What's the benefit of you having is RS5 or later as a named member that took no parameters? Like it reduces only a few characters.
Mm-hmm.
And it would be the example that Jeff had, which would be if you combine them as a compound expression where you say runtime information is OS platform or later and is OS platform earlier than blah, right? Basically, if you want to have a range check. But even then, I would argue that the range check probably reads easy enough, and it's probably in a few enough cases that it's probably fine.
It reads easy enough in English. If I'm not an English-speaking software developer, I might choose to have helper methods that are in my native language.
Maybe. As a German, I'm not convinced I would do this to myself, but but yeah.
And I don't know what it would, if we did some sort of range-based method, then we'd have to handle the case of you pass in iOS, conflicting ranges, like, oh, I want iOS 12 and as the minimum and less than tvOS, something or other, and that starts getting crazy.
Right. Yeah, I would say, like, similar to nullability, let's start with the simple cases, and then as we are basically using this thing ourselves and our customers, you will probably find some cases where the analyzer is not expressive enough, and then we add more attributes to handle that.
Yeah, because I mean, honestly, like thinking of how the analyzer probably works, though I have no idea how the state flow stuff actually works because I skipped that in my analyzer's introduction. Essentially, it's you hit this if, and then inside that lexical scope, you push a new. I now have a new minimum guarantee for iOS, and like so, if you have a thing that just slaps a bunch of attributes of like, hey, if this returns true, then you can assert that the minimum OS is iOS 14 or iPad OS 9 or Mac OS 7 and it's less than TV OS 97 and essentially it's just pushing things into the state machine of the analyzer.
Yeah, so
literally the same state that it would be carrying. So we could do it.
I can give you the logical thing how it works. Like, think of the method body as a control flow graph where, statements, but also conditions, right? Like and A and B and C and D, right? This is also control flow because B only gets executed when A was false, right? So like you have basically a complete control flow graph for the method. And then basically what the analyzer does, it effectively has methods like, create state and then merge state, right? Where basically when you have nodes that are joining, you basically merge the states from both branches. And so the state in our analyzer case is basically what is the asserted minimum version and what's the asserted maximum version. And then when the state is basically flown to the graph, well, you're effectively combining these states, right? And then at a given point in time, you can say, well, looking at this code here now, based on the state, what can I assume the minimum and the maximum to be, right? And that's basically what we would do. It's not super complicated. Like it's fairly straightforward, given that the Wasm team now has an actual API that does the flow for us. The only thing we have to do is basically construct the state, right, and override the methods. It's still a fairly complicated API, but logically it's relatively straightforward.
Right, but so it's when you get into the I've hit a flow node and I need to push state into it. It would be go copy the asserts minimum version, all those nodes into your min version state bucket, and asserts maximum version or asserts less than version into your upper bound state. So we could do it. I don't think it would be super complicated, but it means that we'd be adding a bunch of attributes right now for a thing that we don't know that anybody's necessarily going to do.
Right. I think the first thing we'll most likely add to our analyzer is probably environment OS version, because there's probably a fuck ton of code that does that today. And so the problem with that is that basically, similar to what I said earlier, right? Like, because you have not a simple method like here, you basically have .os version .major equals or .major is less than or whatever. And so extracting what the person actually was asking is fairly non-trivial, because there's just a huge ton of combinations that you could interact with, right? The bigger problem with runtime with environment OS version is that, forgot what the name is, but the OS kind enum that we return is completely busted at this point, because many of the members don't make sense. So I think the best we can probably do is we can say we can extract the version number maybe, but if the person tried to detect the operating system, then we're probably out of luck. But I don't know how you extract then the OS at all. Because maybe you can say, well, if we know that the project was targeting .NET Framework, we can assume it's Windows. But then pretty much that's the end of it, right? As soon as I target .NET Core app, I don't know what a version check by itself would mean.
Unfortunately, we've merged with Mono, so you can't make that assertion anymore.
That's, I guess, also true. But yeah.
Okay, so I think the moral of the story is we'll have, so each of these two helper functions, they'll just have string params. We won't do the major, minor, build, revision args at all, right?
Oh,
I thought we were doing both.
Yeah, I would do both. Because technically speaking, it's for the analyzer, it's not super hard, because basically, they're both kind of the same entry point almost.
And all right, that's fine. So we've got, so you can either do a string or you can break down the version number parts, but we would have to document we don't support helper methods around these. You have to use these two methods directly in the guarding code.
Right.
With regards to the analyzer.
With regard to the analyzer for runtime, we're still going to guard you. But if you want the analyzer to work, as you said before, Jeremy, by shipping these at the same time, we'll then get that feedback, and then we just need to ask folks where the pain points are, and see if we need to add, potentially add more helper functions or attributes, and in conjunction with that, enhance the logic of the flow, determine flow logic in the analyzer.
Yep.
Okay. Cool.
Do
Yeah, the
we know-
runtime behavior is it'll work if you do helpers. It's just if you turn on the analyzer to help you understand when you're doing something that doesn't make any sense, that will not understand the helpers.
Do we know how complicated it's going to be to get the JIT to recognize these as constant, given OS platform is a struct that contains an opaque string, and similarly, I guess, for the analyzer, if someone defines their own OS platform static read-only, for example, is the analyzer going to be able to correctly recognize what the string constant for the OS platform is?
No, I mean, same thing. Like, basically, if you don't pass in directly OS platform dot blah, like, I would say that's the same thing as if you pass a variable to the version number. Like, we don't know. Because otherwise you would have to do... The problem is, first of all, you would have to do data flow to find the original thing, but even data flow might not be sufficient, right? Because this thing might be initialized by the constructor.
Or a different assembly.
Oh, yeah, and then it's like, well, I don't even know who, like, where the thing was set. So, like, I don't know how I would find out what value it holds at runtime. And so, yeah, I would generally say you can't do that.
Yeah, so it would need to be a constant expression, whether that be a inline literal or a reference to a const.
Yeah.
Or the analyzer will just say, like, this is not a thing I can reason about. Write code that I can reason about if you would like to use me. But, polite.
So I want to make sure I understood. Again, at runtime it would work fine, but the analyzer would not be able to interpret.
Correct.
Right. And I don't think yes, performance is good to care about, but I don't think it matters if the JIT can optimize this or not, because it means that you're doing complicated things, and if you want to do simple things, just say your minimum version is your minimum version, or say that your target version is your minimum version, and you never have any of these checks.
I don't think that's good, because there's things like DirectX, Metal, and Vulkan, which have OS-specific APIs, which you're going to want to use on hot paths, in which case you're going to want to have these checks so you write it once and it works.
Yeah, so the way I would model those things is it depends on how you want to do this, but like normally I would assume you do this check way high up, right?
For a lot of these APIs, I don't think that's necessarily a good idea. It's similar to intrinsics, where you might have an algorithm which is essentially the same, except for this one particular call, you're going to want to decide, do I do blend or do I do and not or? And which one you do is going to be used in that one spot in a hot loop. And you're going to want the JIT or the AOT compiler to go and drop the dead code path, essentially, to make sure that it is as optimal as possible. It's not going to be this high-level check with a bunch of code you duplicate 5 times over.
I mean, that's fine. I mean, like, what are we doing for OS platform today? Do you know?
Right now, it is not a JIT constant, and there's been complaints from people about it causing perf issues in their hot paths.
So what would we have to do? Like, is it just we attribute this thing, or is there like actually JIT work required to like do
I
stuff?
think there would be JIT work required to recognize OS platform properties here as intrinsic, and then track what they are with regards to other checks to know, okay, the user's passing in OS platform Android. The other 4 parts are constant, so therefore we can emit a constant check and fold it down to a GT true or GT false.
So what is the actual technical term for this? Is like it's called like
constant folding.
Okay, so by the JIT is like basically, I meant more like what's the term for a method that the JIT knows will always return the same value in a given process?
There's basically intrinsics and constants.
Okay.
And the JIT can convert an intrinsic method into a constant in some cases.
Yeah, the thing I don't understand is like they would still have to, like, they know when to run the code, right? Because they have to at least run it once, right? Because they don't know what the answer is, right? They just know that once I know the answer, it will never change.
The compiler would... So, for example, with hardware intrinsics, when the JIT starts up, we query the CPU for what do you support, and we cache the information. In this for this particular scenario, we would know what OS we're running on already, and then we could query what version we're running against and cache that. And then when you encountered such a check, the JIT could fold the values passed in against the values that it has cached and decide to convert that call into a constant true or false, which then allows the dead code to go away.
Yeah, I guess the question is, and that's the thing I'm not entirely sure, because you would basically have to replicate the logic that the method does into the JIT then, right? Because the problem is you would have to either cache all arguments and say for this argument combination I know the answer, or you have to basically replicate this thing and says, yeah, I know I'm running on Mac OS, but if somebody asks for OS X, that's also true, right?
Yep, and we have to do that for things like math.sign and round and things like that. Anywhere where we want to support constant folding, you have to have something that the JIT can fold against.
But for the general problem, I'm aware that making an artificial class hierarchy with a virtual member and then hoping for JIT devirtualization is not grand, but it does get you at least the one time, wait, this was the only object that got created, I know exactly where it's going, it's sealed, stop doing vert calls and just jump to the address. And it's more work you have to do in your code, but until we can make the JIT smarter, it solves the problem.
Yeah, that's fair. I think starting somewhere is probably a good point. I mean, I will start the discussion with the JIT team and then see how much work that is. But I think we should first start implementing the methods anyway to just get a sense for what it would take. Sweet. So any other concerns, or is that it?
Are we going to support debug assert in addition to if in the analyzer?
So there's a separate spec for the analyzer, but yes, I had the same realization 10 minutes ago that we need to support debug asserts as well. The thing is,
when we finish this API, could we take a look on the analyzer issue?
Totally.
Not exactly reviewing, but I could have some question over there.
I mean, that's one of the questions I asked Manish. Like, to me, the debug assert case is that really the way that should be handled is by the control flow engine already. Because logically, they know that if the condition is false, they should basically treat the result as unreachable code. And I think he said they're doing that. The compiler doesn't do that, but we don't use the compiler flow analysis. We use the flow analysis that they wrote for the analyzers.
I think he had tests for the debug assert.
Yeah, I think they're special case debug assert. I think I asked him whether they have a generic attribute for that, but he said no, they're just hardwired debug assert.
I mean, the compiler not accepting debug assert as true is the right answer, because in a release build you don't have that check and you're just hoping. But for things like nullability analysis, it's like, well, you promised in your debug builds that you never saw null get past here, so we'll run it. It'll throw. Like,
if you're wrong, if you're wrong, you get an exception, right? Like, yeah.
Deciding that like the state past here doesn't exist is not a great thing for the compiler to do with debug assert or debug fail, or like your code is still there. EIP or RIP is still there. You just now need to deal with that. Otherwise, it's a runtime assert.
Okay, let me
so I think we've covered this, unless we decide that helper methods are the thing that we need to tackle right now. But I would leave them out for now with the KISS principle.
I'm good with that.
I would have used Yakni, but yeah, same answer. All right. Then I guess I keep doing this. I guess I can remove blocking now. All right, so then, do you know the analyzer issue? Top of your head, Booyah?
I just sent.
Oh, you pasted it in chat. Okay.
I had lots of questions about versioning, but so now attribute doesn't have separate versions, so let's make it a little bit easier, I guess.
So is there anything particular you want to? So we just go top to bottom, or do you want to talk about? Okay.
No, the goal non-goal is the same as yours, so it doesn't matter. And well, for expectation, so APIs need to be that attributes need to be implemented, and all APIs annotated. I'm not sure who's gonna do that and how. But my most concern is the platform context, the below it.
Yeah. Yeah, so like when I wrote this, I tried to write it in a simple way, but apparently it's more complicated than I would have written it differently. But basically, so what I tried to say in the spec when I said platform context, it's basically the idea that the way the analyzer logically works, right? It basically looks at every method call or any member call into your project, and then it says, well, if the API that you are calling is considered platform specific, then we basically have to compare what the API requires with what the call side guarantees. And so basically the idea is that the call side has different kinds where the guarantees are coming from. Right? One is the global context, which is is the project itself specifying anything, right? And so we can probably ignore this entirely, because logically now, this whole stuff is caught by this stuff here, right? Because we don't have OS platform version, we have minimum OS platform attribute, and that is always applied to the call side, right? Because at first it's at the assembly level, right? But like everything within that assembly, when you just walk up the hierarchy, you will eventually hit the assembly level attribute. But the call side itself, the method or the containing type might also have the attribute, right? And so in that sense, you basically just look at that and you say, well, is the call side guaranteed to be that version number? Then I'm fine. Or if it's under a guard, right? These are the only two cases you have to consider effectively, right? This one stuff here you can completely ignore because it's flown into the project as an assembly level attribute.
So right now, what I have is like check TFM, and then also for that call side, the number 2. What you're talking about is the number 3, like checking using that API, check the platform, right?
This one basically handles this one, right? That's what I'm trying to say.
So number 2 is the pretty much checking if the containing method has the attribute.
Right.
But it's not using that runtime is always platform later or earlier.
Correct. It's a static annotation on the call side.
Yeah, it's just checking if it has contains annotation. But well, I thought the one will be like the only one case to check, like easy or faster. It will be same for all entire code, so it's
not
maybe
really
easier if it's,
because you basically always have to walk from the call side outward, right? Because just because the whole assembly is platform specific doesn't necessarily mean that your call side has the same guarantee, right? So you always have to basically say, well, is the containing method attributed? No. If it's containing type attributed? No. If it's containing assembly annotated. And you basically walk this list inward to outward, and then the first hit is basically telling you what the version number is. And then for the most time, yeah, you will basically walk all the way up to the assembly, and then you say, well, the assembly says it's 12, so I guess 12 it is. Does that make sense?
Well, yeah. It
So
just
yeah,
that
there,
it will
yeah,
be faster check, but
yes. So that's why. So that's one thing we I think talked about with Manish last time, right? So the way the analyzer needs to work in general is, you basically only look at call sites where you know that the API you are calling is platform specific. You try to bail as early as possible. Like if the API that you're calling isn't platform specific, there's no point in walking, right? And
Yes.
so that already cuts down 90% of the call sites, and then you only do the walk for the things that are platform specific, but there's no really a way to shortcut that. And then the only other shortcut you have is the next line here, right? So the flow analysis, yeah, you try to shortcut that as well. You're basically saying we only do the flow analysis if the method contains any platform specific call sites, right? And then you do the fallback and say, yep, okay, now let's actually walk the call graph. Or I should say the control flow graph. And so yeah, so this check is really expensive. This one is not super expensive because this one you can also cache, right? Because you can say, well, if I already walked the type, I don't have to walk past the type again, right?
Yep. I have already one and two kind of implemented, but didn't went to now about to start on the number 3, and like. Okay, then. So you mean if TFM is not OS specific, and it doesn't, if TFM has OS specified and it has also version of the OS, then it should just ignore it, whatever
so
it has.
like in your case, this one here
In
kind
my
of
case,
falls out because the thing is, you basically just look for minimum OS platform attribute, right? So if the project itself is net 5, we will not burn in the minimum OS platform attribute, right? So that means the way you detect that the assembly is neutral is by basically just saying, well, do you have a minimum OS platform attribute? You don't have to look at the TFM.
Yeah, for the first section. But if TFM is platform specific, we should check that if that platform is matched, then we don't need to check the number 2 and 3 in that case, if it matches and the platform and version is matched.
You can generally assume that the version number can't be lower. Yes, so like if the project itself, if the project's minimum version number is already enough to call the API, then yes, you don't have to check 2 and 3.
Yeah. Is it this analyzer's job to do the warning for if it does see a minimum higher than or minimum OS version higher than the target framework's embedded OS version, and or if a method is going lower than the assembly lower or the class lower bound?
Sorry, that was a long sentence. Are you asking whether it's legal to have a minimum version that is higher than what's in the TFM?
Right. So if the TFM says iOS 10.12 or says iOS 12, and then the minimum OS version says iOS 14.
Yeah, that's a bug.
So is it this analyzer's job to report that?
I would say no.
So so garbage in, garbage out on that one.
Yes. I mean, really, we should produce a warning for that, but that should come from MS Build, right?
I mean, the MS Build wouldn't know if you've injected the assembly in assembly-info.cs manually. Like if you didn't use the properties, it can't warn. But
fair enough. But like, yeah.
Right. So then there's the state of the assembly says minimum OS is iOS 14, and then some class says the minimum OS is iOS 11. Is it this analyzer's job to warn on that?
So should the analyzer warn if
if the class is lowering the minimum from the assembly.
Minimum OS platform. I think this one, yes. And then I guess in that case, you might as well handle the assembly level one as well, right? Yeah.
Right. So it's a question of, like you've said, it's an invalid state. And so is the analyzer supposed to report on it, or is at every level in this analyzer, is it garbage in, garbage out?
Yes, we should probably handle that case.
Because that would just be again, when figuring out for this type, the first time you have to resolve it, it's like, oh, it has the attribute. Well, now let's compare it to the assembly attribute. Hey, that's an inverted relationship. Produce a warning, and maybe the whole analyzer shuts down because who cares? You're in a broken state at this point. But just figuring out what the error conditions are here, since so many manual attributes have to be applied.
Yes. Yeah, I'll record that in the spec for the analyzer. Like that should be
a different diagnostic than, hey, you're calling a method that you can't call.
Yes.
It's, hey, your attributes are in a nonsense state. Please address. But because the phrase was used here of like, well, that doesn't make sense and that's an invalid state. It's like, well, is that an assertion or a verified fact? So.
Yes. Okay, does that make sense to you, Booyah? Do you understand the flow now?
Well, I didn't exactly understand the Jeremy's point, but for others, I'm good.
That's okay. Jeremy's points are usually so esoteric, even he doesn't understand them.
I mean, I understand that if it's not very strange numbers found within the versions of OS, then we should report that.
Right.
But
yeah. Right. Emo had suggested that if an assembly, a class, and a method all have the attribute, they have to be getting more and more restrictive instead of you're allowed to get more permissive. And then I felt like asking the question of, is the analyzer checking that, or is the analyzer simply believing that to be true?
Well, that was actually my question in my list of questions. What if it's in such case? Yeah.
And did I understand right there that the recommendation is, if we do find that we're in a bad state because the values conflict with one another, then the analyzer would essentially turn itself off and just report one diagnostic that we can't proceed?
Yeah, so the way analyzer works is that you basically can decide what you're walking. And so I would say we should probably have in the registration where we say what we want to walk, we should also walk the declared symbols in the project. So that means you would basically walk, every declared type, method, and so on once, and you basically just compare the minimum OS platform version if it's present with the target platform version, and if you find any one that is higher, you report errors for all of them. And so that basically means you're reporting the error once, and then yes, of course, the analysis that you will know for these methods will be incorrect.
Yeah, so it's sort of a pre-validation pass.
Yeah.
And if it reported anything in the pre-validate, then it doesn't move on to the full validate.
Yeah, that one I'm not sure how you tackle these two together, but yeah.
Yeah, I mean, you can still run it. I guess the pre-validate's telling you anything that I say past this point might be garbage. Expected semicolon.
Yeah, but usually you try to avoid the report cascading errors, right? Because then you're...
Right.
I mean, I guess if this is an error, the other ones are warnings. It will probably bubble to the top by severity. But yes, we should logically, we should probably not analyze methods where we reported an error for the attribute that was applied to it or its containing type.
Boya, you had I think you had started talking a minute or so ago, but cut out.
me? No.
Okay, just checking. Thanks.
I had lots of questions about the versioning because in pairwise attribute it was required. So, and the OS platform check has not required all the versions, that is earlier than or whatever. It has overloads, not using all the numbers, but I guess now I'm good because we are not requiring all the versions for the attribute.
So, is the question of how you compare them, or?
Yeah, if, for example, TFM doesn't have any, has OS specific, like iOS, whatever, but doesn't have the versioning, then right now it will be like 000 for in my calculation because the versions are required. But
So, sorry, where do you mean the version number is omitted? You mean in the project file it's omitted, or?
no, for example, in TFM, in the project settings,
Yeah.
if TFM like net5 and -o iOS without version number, then
Right.
what version it should be
Yeah. So that
fall into. And
so I haven't called this out here, but it's called out in the TFM spec. So basically, the idea is I guess you don't have an example here. So if you omit the version number in the project file, that during build we know what version number this is. So the idea is that if you say net5-iOS with no version number, the SDK knows, well, net5 ships initially with iOS 10. So then the attribute that we generate will have 10 in it. So that's why, generally speaking, you shouldn't look at the TFM. You should just look at the generated attribute. And the attribute will always have a version number. There's no such thing as a versionless TFM in that sense. It's just convenience that the person didn't have to specify it in the project file. But if you ask for it, there's always going to be a version number.
You mean that attribute generated from build?
Yes. So basically, the assembly level attribute, that is the minimum OS platform attribute that is generated out of the TFM, and the target platform attribute that we have, those will always have version numbers.
What's the attribute name?
So
I have added that
let me
target platform minimum version, but that one was empty.
Yeah, so like if
it wasn't provided.
So if you say something like this, right? If you say net5-iOS and no version number, we know during build that when net5 shipped, the version of iOS we supported was 12. So basically, if you omit the version number, it will always mean the same version number. And like at build time, we will know what that version number is because it's hardwired into the SDK. And so even if you omit the version number, if the version number that we bundled with net5 was iOS 12, target platform will still say iOS 12. And then if you didn't specify this property here, then we just set it to this one. So you will always have a minimum platform version. And it's either exactly this or a lower version number, but there's always a version number. And like in your case, if you just look at these attributes, there's always going to be a version number. The project file might not have it, but that doesn't matter.
These attributes aren't always present, though, right? Like a
platform
neutral assembly does not have these attributes.
Well, if you say net5, then yes. So that's what I'm saying. So if you're platform agnostic, then yes. The way you find out is because these attributes are not present.
Right. But once these attributes exist, they will have an OS and a version.
Yes, they're illegal without it.
So I just can expect these attributes will always exist.
Yes.
I mean, at least target platform.
Well, if they are present, they will have a version number. If they're not present, it means the assembly is platform neutral, which means you shouldn't be able to call any platform specific APIs. So everything you call should be a warning.
Everything with a OS or everything with a platform guard is a warning. Not everything is a warning.
Yes,
String works everywhere.
Yes, everything that is not marked otherwise, either via platform guide or via attribute is now warning. Yeah.
Do we, who is related or who's responsible for painting registry and such? And are we doing that in this release?
So my goal is, so once this attribute, so today we approved this one here, right? So like my next task is doing exactly that, like going over the APIs that we know. So let me start differently, right? We have this guy here, github.com platform compatible, right? Which was our first analyzer. And this one basically has a database effectively, right? Which is a glorified way to say that's a CSV file. And the CSV file tells us what is Windows specific. And so I will use that as an input to say where we should sprinkle some attributes. And then I will bring that to API review, probably next week if I get it right. And it's probably just a list of things that we need to put the attribute on.
Are we going to be attributing WinForms and WPF?
I was thinking about that. We will probably not do that because the only way you can reference them is by targeting the platform specific TFM already. So the only reason why the attributes would be useful is for version information. But given that both WPF and WinForms are supported all the way back to Win7, and Win7 is the minimum that we support in general, it's just overkill at this point.
What about Mono? Since Mono supports WinForms and registry at a minimum, and those work cross-plat.
So if you use Mono, then none of this makes any sense, right? Because if you're using Mono, you use the .NET Framework reference assemblies anyway, so the attribution doesn't buy you anything.
Okay.
So like this is only when you compile for Net 5, right? Otherwise, you won't see the attributes to begin with.
Yeah. And then the mono versus core CLR doesn't matter at that point because it's the same reference assemblies.
Right. But I mean, so I asked this the WinForms team at some point because I said, like, you keep adding these new APIs. How many of them are actually supported on all platforms that .NET Core runs on? And so far, everything they added is supported everywhere. So, but eventually they may have a property that only works when you're on Win 10 or up or something, right? And then we may actually put the attribute on those guys as well.
Yeah, I feel like right now they're still excited to get caught up with Vista.
Yeah, I think that's true. But I think registry is a good example, right? I would probably just mark all of registry as Win7, right? That makes probably the most sense. As opposed to put an attribute in every single type, right?
Yep. And the fact that all of our ACL stuff for I/O and the like are in a separate assembly means we have one place to slap all that to.
Yeah, there's a few cases where we couldn't, right? But like that's actually the nice thing with these attributes, you can apply them at any level.
But okay, so it is a goal for 5 that the shared runtime is properly annotated with this.
I wouldn't go that far, but yes.
It is a hope for 5 that the shared runtime is properly annotated.
Yeah, okay, let me write this down. If
you prefer hope instead of goal, we can soften the statement.
We should make sure that all.
And if it's not, I'm see also the discussion of, do we want to have the high level review of every nullable annotation that has been added in the last year? How much time do we need to spend on painting assemblies with stuff that we shipped 20 years ago?
Yes. Right. This whole thing very much came out of, like, this is what iOS and Android do already, so can we make the experience better there? And then a logical progression is, okay, if things in CoreFX have the same problems, or like, then it makes sense to apply there. But that's not so much the primary goal, more a kind of logical progression.
Mm-hmm. And I assume for the concept formerly known as Xamarin, that this is already being taken care of for where it's exposing the platform APIs, right?
The annotations exist. Just it's not using these exact attributes. Of course, they have their own attributes.
Right.
Um,
Yeah, I think to me it's important that we get the broad strokes right. It would be pretty dumb if registry wouldn't be annotated, right? That seems like or WMI wouldn't be annotated, right? Or system.directory services wouldn't be annotated because we know that they're all Windows specific, right?
Well, we just made half of directory services work on non-Windows platforms.
Okay, so then maybe no longer, but for a very long time was Windows only, right? Because we just p-invoked into Windows. If we now have a cross-platform implementation, that's great.
Yep.
Sweet. So then, anything do we need to do for this one here then? Do we need to approve this guy?
Did you have any further questions in the analyzer, Booyah?
I don't think so, because it's based on the previous attributes, so it needs to be updated too. So, I guess doesn't need to be approved.
Yeah. In here, Emo, I assume you've spec'd out what it means for saying iOS 12 versus iOS 12, comma 0. Like, are we zero filling with the overloads?
I haven't called it out, but yes, I mean that's the only sensible behavior, right? Because system.version doesn't do that, and it compares them differently, which I think is dumb because I don't think anybody can reason about that. Like, because the whole contract of these methods is you basically ask, are you running on this platform or a later version of it, right? So like everything you didn't specify is implicitly 0.
Right. So iOS 13, which is about halfway in the screen right now, that will be true for 13 RTM and 13.1
Yes.
and 14 and etc., but not 12.9, which is, it sounds very stupid to say this out loud, but as you said, system.version has different feelings on this 13.0.0. How does that compare to 13 or 13.0? And so I'm just making sure we've addressed that.
Yeah, we do sensible comparisons here. We don't do crazy comparisons. Yeah, I should probably call this out in the spec somewhere.
Yeah. And do we know of any? Do we have any system that's using a 4-component version with a API set?
No, the maximum I think was 3.
Okay.
But like,
we're building it out because we know that that's as far as things go, and we don't want to get caught later with a thing we couldn't express.
Yeah, like I mean, version numbers are always 4 components, right? So like we might as well.
Okay.
I mean, I sincerely hope nobody ever does that, but I think to Michaela's point earlier, right? I do think we probably never use it for the OS version, right? But we may actually end up doing it for the SDK, because if you have, if a platform uses 3 digits to indicate its support for APIs, well, then maybe we need to rev our SDK one more step, right? So that means you may have to actually have a 4th digit for the SDK.
Yeah.
So
like, I don't know that Apple introduced APIs in it, but when it was OS X, I think it was, 10.14.1 was the first update to 10.14. And if they added a new API, then we would have needed 3 characters. And then, is there just asking a high-level question, is there a notion that someone might want to use this for, I know that there was a bug in 10.14.0 and I don't run unless you have 10.14.1 or higher.
No.
Or is that a non-goal for this?
No, that's the same thing that we do for targeting packs, right? We do not allow you to prereq bug fixes. I mean, you can of course use the APIs we have to check for that, but and we can't really stop you from doing that, right? I mean, you can totally annotate your assembly with, I require the minimum version number 10.3.4.2, and you will get the right behavior out of the system, but you wouldn't be able to express that as TFMs, right? So
Okay. I'm just asking all the related questions I can think of while we're looking at the subject.
No, totally fine.
So one last question.
Sorry.
Sorry, go ahead.
Oh, yeah. If you do know that it is specifically an OS bug, then I guess it would make sense to use that. but you certainly shouldn't use it for framework bugs or binding bugs.
Right, but we would expect, or we would not expect that we would ever do that in any of our metadata, and we would not recommend someone do it with their metadata, but they could.
Yeah, not unless we know that some API is like literally unusable. But
I mean,
odds of that happening, I don't know.
I mean, I would expect us to do quirking in the implementation using these APIs, but I don't think we would ever expose it as an attribute somewhere.
Sure.
I have a question for the attribute versioning. So now they don't have separate version and it will be attached to the string. So that means like not all the version parts are not exist. I'm thinking just if it says like iOS 13, then if there is another annotation found, like suppressing annotation or something found like iOS 13.1 or whatever, then I would just ignore the missing part or make it 0.
Jeremy, is that what you were just explaining with the, would you call it spreading 0 or something?
Yeah, zero fill, I think is what I said.
Kind of
Zero
similar.
fill.
Yeah, so I think the answer is if something says minimum OS version iOS 1.3 and then a close quote, that is the same as if they said 13.0.0.0. Logically, whether or not we normalize those states, but as far as the comparison is concerned, 13 and 13.0.0.0 are the same thing.
Okay, just making sure, because I thought now we can ignore it, but okay.
Yeah, I mean, basically the way to think about it, you bring all version numbers into a 4-digit space, right? And then if anything that wasn't specified, you use 0, and then you compare.
That just makes a little bit strange. So I thought now we can ignore that, because just concentrate on the the number we already have.
I'm not sure what you mean by ignore. I mean, that's basically the equivalent of 0
I mean,
filling.
if the numbers are missing, then, for example, I have one attribute 13, iOS 13 attribute in the calling method, and but that method is suppressed with the 13.1. Then for evaluating if I need to warn it or not, I just ignore the missing part, like just check for that numbers 13, like first major, and ignore the remaining part.
Well, no, because if the caller says he's just iOS 13, that would be 13.0, and if he's calling a 13.1, that would be a warning.
Right.
Okay. Then nothing much changed.
All right.
Sweet.
Congratulations, Emo. We solved it in one.
We solved it in one pass, yeah. Well, okay, I'll update the analyzer spec with the things we talked about, all including the attributes that we now approved. And I will call out some of the details. Sweet. Then that was that. Cool. Then I wish you guys a great weekend. Everybody, I will see you later today. I see you later today, and then enjoy
Okay, thank you.
Enjoy the rest. Bye bye.
Thanks.
Bye.